Hello teacher, today we will analyze our product 2. We will observe through changes in multiple size of data and graphics, and by writing code, the shape of the polyline changes with data. At first, VBA is just an object-oriented programming language. Visual Basic Editor is Visual Basic's development environment. Objects are a set of codes and data. The properties of the object are utilized to define the characteristics of the object. The methods of the object refer to the behavior of the object. A macro is a set of instructions for recording VBA programs. For users who need to get to frequently use the Office suite software in their work, learning VBA helps to automate work and improve work efficiency. As we all know, as time passes, the curve of stock prices will change due to economic, political, market, and corporate factors. The stable operation of the stock market plays a significant role in promoting economic progress. We have now utilized the time days to create a model that simulates stock prices from May 16th to May 26th, assuming a stock price of $20 per share for a total purchase of 100 days. The expected return is 20% and the volatility is 25%. In the simulation model we created, we can directly observe the changes of all stock prices within 10 days. And on the left side of this sound file, we can understand that the data in the series are constantly changing by pressing the colored buttons. At the same time, the polyline in the image will obviously move according to the change of the number. However, in this model, the future stock price will still be impacted by numerous factors, so we cannot predict the future stock price trade based on the previous stock price. In 100 days of our hypothetical case 1, we obtained a total of 300 different unit data. We have divided them into 3 separate parts for analysis, namely stock prices, certain parts, and uncertain parts. Of the 300 data, the average value is 23.1. The minimum value is minus 1.7, and the maximum value is 48.3. For this data, we finally got a line change by writing code in the Visual Basic project. We use orange lines to indicate stock prices, yellow to indicate certain parts, and green to indicate uncertain parts. In this picture, we can first see that a certain part has not been affected by any factors. It has constantly increased at the 20% rate of return we set. On the contrary, the uncertainties and the curve of the stock price are relatively the same. However, we can note that the overall trend of the fault line is upward. But there are common fluctuations. On the 92nd day, the stock price reached a maximum of 48.3. When we press the case 1 button on the left, all the values and the polylines in the table have changed. This also makes use of the user to change the numerical variables at any time, so as to draw new conclusions for more accurate analysis.
In the second set of 300 values, the average was 10.3, the minimum was minus 23.7, and the maximum was 39.3. In this picture, we can see for the first time that some parts are steadily growing. As for the line of the stock price, compared with the old line of the previous set of data, this set of data is more unwavering, but it still has fluctuations. We can see that the previous line has generally risen, but there have been frequently fluctuations. Between the 18th and the 26th day, there is a considerable floating decline in the values. On the 69th day, the stock price reached a minimum of 10.8. However, in this set of data, the uncertainty line is distinct from the stock price line, which shows a slight downward tendency. Then, we made use of some method to get multiple polygonal charts of the same structure. It can be observed that once the initial value is set, the polyline will not change. As Chunyi Gu said earlier, the polyline and the uncertainty line will change as the data change. In the process of creating the simulation model, we found that all programming links are closely related to geometric Brownian motion. Geometric Brownian motion is in the form of changing numbers while satisfying the stochastic differential equation. Its formula consists of determining factors and uncertainties in illustration. It contains the expected rate of return in a very short period of time and a random value in a normal distribution, with a mean of 0 and a standard deviation of 1. A normal distribution means that the actual values it displays are all unknown random variables. In a customary distribution series, the average is 16.3, the minimum is minus 10.4, and the maximum is 39.3. On the 1970th day, the stock price reached a maximum of 33.3. The uncertain part reached the minimum value of minus 10.4 on the 76th day. As in the case of analyzing case 1, there is no changes in the value of specified part. Finally, we discussed the data from a log-normal distribution. In the log-normal distribution, there is a definite probability of its random variable. In the log-normal distribution series, the average value is 22.1, the minimum value is minus 4.3, and the maximum value is 55.8. On the 100th day, the stock price reached a maximum of 55.8. The uncertain part reached a minimum of minus 4.3 on the 76th day. In the same way, the value of a specified part is the same without any change. Based on the above analysis, the Visual Basic project helped us improve our work efficiency and automate this processing. It facilitates users to substitute their required data and quickly and accurately obtain all variables and invariants based on the code edited by the user. By understanding geometric Brownian motion, we simulated the stock price over a certain period of time. The presentation of this method can make us intuitively observe the ups and downs of the stock price within the specified time period. Thank you for your listening.